Percent composition and empirical formulas are both kind of based off of things that we've done already. Percent composition, we're going to be looking at molecular mass and just doing one extra step with that. Empirical formulas, we're going to be doing gram to mole conversions and then doing another step or two on top of that as well. So for percent composition, we're just looking for the relative amount of an element in a compound. So you can see the equation that's right here. The mass of the element in the compound divided by the mass of the entire compound times 100. So just like you've been doing with finding molecular mass, you need to start by finding the total molecular mass of this compound. So for the first example here, we have K2CrO4. So to add up the mass, you're going to start with, get a pen going here. You're going to have 2 times the mass of potassium, which is 39, we'll call it 39.1. So 78.2, plus the mass of chromium, which is, we'll just round it and call it 52, plus 4 times 16, which is oxygen, and add it all up and get 194.2. So that is the mass of K2CrO4. To find the percent composition of that, you just take each individual element's mass and divide it by the total. So for potassium, the mass is right here at 78.2. So if we divide that by 194.2 and multiply by 100, we should get its percentage, and its percentage is 40.27%. So all that means is 40.27% of the total mass is potassium. For chromium, we take the 52 divided by 194.2 times 100, solve, and it's 26.78%. Now, to solve for oxygen, you can do one of two things. You can subtract the 26.78 and the 40.27 from 100%, because the rest of the mass should be oxygen. Or you can just take the 4 times 16, which is 64, divided by the entire mass, 194.2, multiply by 100, and solve for its percentage, which is 32.96%. For the question down here, it says, what is the percentage of carbon in calcium carbonate? So you just want one element, not each individual element. So you have to first figure out what calcium carbonate is. So putting it together using the rules that we've used in the past, calcium, look up its charge off the periodic table, it's 2+. Carbonate is CO3, 2-. So calcium carbonate is CaCO3. Add up the mass. This is 40. This is 12. This is 3 times 16, which is 48. Add it all up, and it is 100. So the percent of carbon is 12 divided by the total, 100, times 100. So it's just 12%. And that's all you have to do. For empirical formulas, we're looking for the lowest whole number ratio of atoms in a compound. So you have 3 examples here, and it says, what is the empirical formula for each of the following? So if you notice right here, with C6H12O6, you can divide each of those numbers by 6. So the empirical formula is CH2O, just those 3 things divided by 6 each. Here, N2O4, they're both divisible by 2, so you have NO2. And here they're both divisible by 3, so you have BH2. So that's all you're looking for, the lowest whole number ratio. Now when we do this, we're going to look at 4 steps to solve for that lowest whole number ratio in a problem. Okay? So our sample problem here says, what is the empirical formula of a compound containing 20.23% aluminum and 79.77% chlorine? So basically all this means is that some analysis was done. We know what the percent of aluminum and chlorine is in a compound. And we know that's the only 2 elements it contains. So from this information, we're going to solve for the empirical formula, so the lowest whole number ratio. The first thing we're going to do is assume we have a 100-gram sample, which allows us to convert the percentages to grams. So if we assume we have a 100-gram sample, and we have 20.23% of that is aluminum, then 20.23 grams of aluminum would be in 100 grams. Same thing with chlorine. If 79.77% of our compound is chlorine, and we have 100 grams, that means 79.77 grams of chlorine. This is aluminum. So that's the first step. The next step, convert the grams of each element into moles. Well, we can do this. This is 20.23 grams of aluminum times line. We want to get rid of grams. We want to convert to moles. There's always 1 mole. We're going to go to the periodic table and look up the molar mass of aluminum. It's 27. And I'm going to get roughly 0.75 moles. Same thing here, 79.77 grams of chlorine times grams on the bottom, moles up top, because that's what we're striving for. There's 1 mole. It's 35.45 of the periodic table. Solve, and you get 2.25 moles. So step number 1, assume you have the 100 gram sample. Step number 2, convert to moles. Oops. Step number 3, try and get a problem that actually works. We're just going to ignore what's written there and kind of go from here. So what we solved for on the other side, I'm just going to kind of bring it here, is we had a 0.75 moles of aluminum and we had 2.25 moles of chlorine. Our next step is to divide by the smallest number of moles. Well, 0.75 is smaller than 2.25, so we're going to divide by 0.75, divide by 0.75. This is 1, this is 3. Step number 4, make sure that you have whole numbers as a result of the dividing. Well, we do. We have 1 and 3. If we do, we can write out the empirical formula. So our empirical formula is Al, since we have 1 of them, Cl, 3. If you don't, you have to multiply your answers to get a whole number. And we'll talk more about that when we see an example with that. So now let's go through and do a second example and just work through all 4 steps all at once. Okay? So first thing, assume you have a 100 gram sample. So 24.74% means 24.74 grams of potassium. It means we have 34.76 grams of manganese and 40.50 grams of oxygen. Again, just taking the percentages, assuming we have a 100 gram sample. Convert each one to moles. So grams, 1 mole up top. For potassium, it's 39.1. For manganese, we have 1 mole is 54, we'll just call it 0.9 grams. And for oxygen, 1 mole is 16 grams. Solve each of these problems. So you're going to be dividing because those molar masses are below the line. You have 0.63, you have 0.63, and 2.53. So that's step 1, assume we have 100 grams. Step 2, convert to moles. Step 3, divide by the smallest number of moles. You can see 2 of them are 0.63 and that's the lowest, so it doesn't matter which one you really are dividing by here. Divide by 0.63, divide by 0.63, divide by 0.63. Here you have 1, 1, 4. Are those all whole numbers? And the answer is yes. So we can just write out our empirical formula. We have 1K, 1Mn, and 4 O's.